What is the type of operation that you should focus on first when you're designing an interface? And I'm talking before you start doing anything else, including thinking about the names or thinking about what kind of data you need to store. What is the thing that you should be focused on first? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So, we've got these operations in our interface. We've got some entity, and we want to define the meaning of this entity. And by meaning, I simply mean, what can you do with it? Okay, what information can you get out of it? So those are your accessors, if you want to give that a name. How can I change this thing? Immutably, of course, you're returning a changed copy, a modified copy. So the operations about how to modify it. How do I make one? The constructors. But then, how do I compose things? Right? To me, that is the hardest part of it. How do I compose them? So let's think about an abstraction that has existed for a long time, well before computers existed. It's the abstraction of double-entry bookkeeping. It's a system of accounting that basically everyone uses now. And it was invented in the 14th century. And it was, you could credit it with the rise of the modern financial system because it was that important. And it's a system where it records data, so it's a data system, an information system. Records data about transactions, but it has this interesting property to it, which is that it tells you how to add a new transaction. So a naive approach to accounting would be when someone deposits $10, you erase the old amount in their account and you add $10 to it and you write that down, right? But in double entry bookkeeping, every account has a book, or at least a page in the book. And what you do is you just write down all the information about that transaction. Where does when you boil it down, which they've done over the years, you have an amount, you have the account that is being debited, and you have an account that is being credited. Okay, so there's three pieces of information, and then of course you want the date and stuff like that. But there are three pieces of information that constitute that transaction. And the interesting thing to me is that before you even think about what pieces of data are in that transaction, you have the idea of how you combine transactions. So you have this book, which is a collection of transactions, and you have a new transaction you want to combine onto it. What do? Well, you always append it to the end. You never modify anything that's already in there. You just append a new transaction on a new line in the book. And even if there's a mistake, this is the discipline of accounting, even if there's a mistake, you write a note and you amend a new transaction to correct that mistake. You never go back and change those old things because you want a record of the mistake too. Okay. So what's interesting about this from a functional programming perspective is that it actually starts with this combined function, this compose function. When you add a transaction to the ledger, the book, you are doing it in a disciplined way. It's append only. And we need to do that when we are designing our data. We need to think, how do I combine this? How do I add new data to my system? Right? Now, I'm not saying you have to do append only. I'm saying you should start with the combinations of data. You should start with the functions, the operations, the calculations, if you will, that take two pieces of data and combine them into a third piece of data. Because these are the ones that, these are the hardest to design, and they're the ones that are going to constrain the representation of that data the most. Okay, so like notice in a ledger, in an accounting book, it's append only, which implies an order, and it applies a place to add new stuff at the end, right? So you're already constrained in what kind of data structure you can use for your ledger. You're not so constrained in how you represent each transaction. You'd probably use a map with a debit, a credit, and an amount, probably the date, and maybe some metadata on it, like who recorded this transaction, stuff like that. But in principle, if it's a map, you can always add that stuff, and some systems might be interested in it, some might not. But it's less constrained. It's obviously less constrained. What's constrained is the operation, or what is constraining is the operation of adding. And so it really helps you design, because the constraint will help you navigate all the possible options for how you design this data, because it'll eliminate so many that don't, like, it wouldn't make sense for your ledger to be a map, not just a map, because how do you add stuff? How do you append to a map? It doesn't make sense because there's no order. All right, so my suggestion when you're building a system using functional programming and you're designing your data first, and then you're saying, well, how do we, what are our operations on this data? You start with the composition operations. So you're designing the data, but to design the data, you need even to think about something even before that. Or, as a subset of that, the first thing you design is your composition. So list out all the operations and look at the ones that are composing things. Now, it may turn out that in the end, even in the last time I talked about something like a person entity and how you might have a change first name operation. Well, if you're doing something like a transaction ledger, you never change anything. You never return a ledger with a modified transaction. So you might eventually get there with your person entity. That the person entity is not just a key value store, a map of data values. It might be a ledger. It might be a list of all the operations you've performed on it. So first, set the name, set the address, set the whatever you have to do for this person. And then if you need to set the name again, you just append another set name operation to it. That might happen, okay? Like the more functional you turn your mutable data, the more it becomes something like that. At least for the main entities in your domain, in your business. But that's not what I'm really talking about right now. What I'm talking about is the combining forms. What I was trying to say was that the combining forms may start to look like, even the like change name operation may start to look more like a combining form. That you're combining an existing person entity with a first name, and you're getting a new person entity out of it. You can think of them like that if you wish. But what is a good example of a combining form that's not something so person entity-ish? Because you never really combine two entities, not really, or two person entities at least. Well, that's not true. Okay, so like, you're working in a distributed system. You probably are. You're on the web, and so one system receives a message that says change the first name, and then another system receives a message that says change the last name, and you want to reconcile these two changes. So you've got a person entity you got two person entities that have the same ID, but they have different data. How do you combine them? Right? You might have to combine these two. In like, if you're making all right, I have a perfect example. I have a contact database that I've been maintaining for years. It's just the people I know and their phone numbers and their email addresses and stuff. And sometimes I'll update one on my phone because I've got my phone, and sometimes I'll update one on my computer. And then when they sync, there's usually a problem, right? The problem is like, which one is newer, right? It's like the computer can't figure it out. And I believe that the system is just designed improperly, that they should be able to figure out which operations to keep and what has been overwritten. And what they're basically doing is combining two records for the same person and determining what is the most up-to-date version of all the information. And that doesn't seem like such a hard problem, but I know what they did is they never thought about the composition until it was a problem. If you think about the composition first, because you're in a distributed system, you're going to have to combine to it. Your syncing is a first-class operation. You should make an operation, maybe it's called sync, that takes two copies of the same entity and determines which one, what should it look like now, knowing that these two things were recorded. And you should start with that, because if you start with that, you start to think, well, if I want some kind of thing that says I want to keep the most recent version, because if you modify it on your phone, you say you modify the phone number on your phone and you modify the email address at your desktop, then when you combine them, I want to know that email address is newer, on the one from the desktop is newer than the one on the phone. So I need to replace the one on the phone. And so if you need to know newer, you need a date or a timestamp when it was written. And so you need to keep that. That has to be part of your data. And it becomes clear that I need that as part of my data to make this thing work. Whereas if you do it I guess I'll call it the naive way, and you think syncing can wait, and you've designed your data to just be a key value store, first name, last name, phone number, email address, which works for most operations, I'm not going to lie, that's the truth, it will work. But then when you come to this operation which you've been putting off, which is called sync, oh wow, I need to store, it's really hard if I don't have a timestamp on every piece of information in here. And so then you need to go back and redesign your data structures so that they can be combined. that's what you got to do. So that's why I suggest starting with it first. Start with the composition. Because everything else is trivial once you have that. Like modifying, changing the name, that's easy. Changing the email address, that's easy. But what do I need to capture? What is in my data model? Those combining forms are the hardest, they're the most complicated, and they therefore constrain your problem the most. So they make the design of the data structures really easy. All right. So if you have enjoyed this, please share it with your friends, subscribe. You can follow me on Twitter. I always love to hear comments, questions, suggestions, complaints, compliments. On Twitter, I'm at Eric Normand with a D. And my email is eric@lispcast.com. If you want something longer that won't fit on Twitter, happy to receive your email. I promise I will respond. So, thank you so much, and I'll see you next time.